age 4, in a wealthy Sicilian home, Ettore Majorana could mentally multiply numbers faster than a machine, a prodigy whose genius reshaped physics and stunned even Enrico Fermi. But before his theories could change the world, he vanished without a trace. Was it escape, foresight of disaster, or something stranger? The answer begins with the rise of a mind science still can't explain. Ettore Majorana was born on August 5, 1906, in Catania, Sicily, a city where privilege and intellect ran in the family veins. His grandfather, Salvatore Majorana Calvino, shaped policy as a member of the Italian parliament. His father, Fabio, was an engineer who brought telephones and hydroelectric power to Sicily, founding the island's first telephone company. His uncle Quirino was already making a name for himself in physics, experimenting with the mysteries of electromagnetism. This was no ordinary household. The Majoranas expected achievement, and they got it in spades. From the time he could speak, Ettore's mind worked differently. At 4, he stunned relatives by multiplying 3-digit numbers in his head, calculations that amazed everyone, and by age 10, he was extracting cube roots faster than adults could write them down. Family stories tell of him sitting quietly at the table while grown-ups argued over sums, only to interrupt with the answer, never needing pencil or paper. Jesuit teachers in Catania soon realized they weren't dealing with a typical student. Ettore's classmates would line up with their math homework, hoping for a glimpse of how he found answers so quickly. He rarely explained. He simply knew. In 1923, at just 17, Majorana graduated from Jesuit boarding school and moved to Rome. There, he enrolled in engineering at the University of Rome, following the safe, prestigious path his family expected. But the lectures left him restless. The mechanics of bridges and circuits felt like busy work to a mind already racing ahead. He spent hours alone, working through advanced mathematics, sometimes ignoring the world around him completely. Everything changed in 1928. That year, a fellow student named Emilio Segre convinced him to meet Enrico Fermi, the rising star of Italian physics. Fermi recognized Majorana's talent immediately, urging him to switch from engineering to physics. It was a leap into the unknown, but for Majorana, it finally felt like home. In the basement labs of Rome, surrounded by the hum of new ideas, a young man who once beat calculators at their own game was about to challenge the science and boundaries of research itself. Via Pinisperna 89 in Rome was more than a street address. It was the center of Italian physics in the early 1930s, a basement laboratory alive with ideas and personalities that would change science forever. Enrico Fermi, known as the Pope for his authority, led a group of young physicists who called themselves the Via Pinisperna Boys. Among them, Ettore Majorana stood apart. His colleagues called him the Grand Inquisitor, not out of fear, but respect. He would walk into the lab, listen to a problem, and, with barely a glance at the blackboard, reveal a solution others had missed. No notes, no drafts, just answers. In 1932, French physicists reported strange radiation from beryllium. The world thought it was gamma rays. Majorana disagreed. He told Fermi, "That's not gamma rays. That's a neutral particle, as heavy as a proton." The neutron. Fermi urged him to publish, but Majorana shrugged it off. Months later, James Chadwick announced the neutron and took the Nobel Prize. The group watched as the world caught up to what Majorana had spotted in a glance. Fermi recognized Majorana's rare mind and sent him to Leipzig in 1933 to work with Werner Heisenberg. There, Majorana developed a new theory explaining how protons and neutrons bind together inside the nucleus. He used the idea of symmetry, forces that act the same way no matter which particle you choose. This paper, published in 1933, became a foundation for nuclear physics. Heisenberg himself would later describe Majorana's approach as both beautiful and ahead of its time. But Majorana's most lasting idea came in November 1937. In a single paper, he proposed that some particles, like neutrinos, could be their own antiparticles. This concept, now known as the Majorana fermion, would become the backbone of modern quantum technology. If true, it could explain why the universe is filled with matter instead of annihilating itself in a flash of energy. Today, the world's most advanced quantum computers are chasing the particles Majorana described almost 90 years ago. For the Via Pinisperna boys, Majorana was the mind everyone measured themselves against. Each breakthrough added to the sense that his disappearance would leave a void no one could fill. March 25th, 1938. Ettore Majorana, just 31 and newly appointed professor in Naples, walks into his bank and withdraws all his savings, enough to live for months. He retrieves his passport, leaves his apartment, and boards the Tirrenia steamship bound for Palermo. Before departing, he leaves 2 letters for his colleague Antonio Corelli. The first is heavy. I have made a decision that has become inevitable. There isn't a bit of selfishness in it. Please forgive me. The words sound final, almost like a farewell. Panic spreads among his friends and colleagues. But the story takes a sharp turn in Palermo. A second letter arrives. The sea has rejected me, and I will be back tomorrow. The tone shifts. Now there is hope, or maybe confusion. Then a telegram. I will be in Naples tomorrow morning. That night, a man matching Majorana's description is seen in a third-class cabin on the return voyage. Professor Vittorio Strazzeri, who shared the compartment, later insists it was him. Yet, when the ship docks, Majorana is nowhere to be found. His room in Naples remains untouched, his passport has vanished, and the money is gone. Police are alerted within hours. The investigation quickly escalates. Naples authorities launch a search, combing through ports, hotels, and train stations. The case draws attention all the way to Rome. Enrico Fermi, desperate for answers, appeals directly to Mussolini for help. The fascist government, eager to avoid scandal, orders checks at monasteries, hospitals, and border crossings. The search turns up nothing. No body, no luggage, no sightings that hold up. As days pass, the sense of urgency turns to disbelief. Fermi, who knew Majorana better than anyone, sums it up. Ettore was too intelligent. If he decided to disappear, no one will ever find him. The facts are all that remain. A brilliant physicist, a bank withdrawal, cryptic letters, a vanished passport, and a trail that ends at the water's edge. Rumors filled the void left by Majorana's disappearance. Some whispered he would retreat into monastic life. Monsignor Riccieri, his confessor, insisted, "Suicide? Absolutely not. Leave him alone." Over the years, stories surfaced. A silent man resembling Majorana, glimpsed in the San Pasquale convent near Naples. He moved through the cloisters, never appearing in official records. When pressed, the guardian father simply said, "Why do you want to know? Leave him alone." Another theory led across the Atlantic. In 1955, Francesco Fasani, an Italian mechanic in Venezuela, met a countryman named Mr. Beanie. Beanie drove a yellow Studebaker, its seats piled with papers covered in equations. He kept to himself, vanished for weeks, and refused photographs. Desperate for a loan, Fasani convinced Beanie to pose for a single picture outside a currency exchange on June 12, 1955. Decades later, forensic experts in Rome compared the photo to images of Majorana, finding 10 points of facial similarity. Fasani also found a 1920 postcard in Beanie's car, written by Quirino Majorana, Ettore's uncle. In 2015, the Rome prosecutor's office announced Majorana had lived in Venezuela from 1955 to 1959, but there were no immigration records, no DNA, only a photograph and scattered memories. Majorana's family rejected the claim. In 2025, a Rome court declared him legally dead as of March 26, 1938, dismissing the Venezuela story. The mystery took on an ethical edge. Leonardo Sciascia argued Majorana foresaw the dangers of nuclear weapons. Warning: physics is on the wrong track. His friends, Fermi, Segre, Pontecorvo, helped build the atomic bomb. Majorana's 1937 theory of particles that are their own antiparticles now drives the race for quantum computing. In 2012, Leo Kauenhoven observed Majorana fermions in nanowires. By 2020, MIT detected them in twisted graphene. Labs like Google and IBM chase his ideas, hoping to unlock stable quantum computers. Experiments like Quarr in Italy set new limits on neutrino-less double beta decay, searching for proof that neutrinos are Majorana particles. His fate remains as elusive as the particles he imagined. Majorana's ideas now power the race for quantum computing, while his disappearance still defies proof. In a world obsessed with finding answers, his greatest legacy may be the questions he left behind. Some mysteries don't fade, they shape the future. What would you have chosen? Brilliance or oblivion?